Good afternoon or good evening, whatever the time may be that you're sitting down to watch this. This is the homework number 37. It's the last one I'm going to give you before the test on Friday. And I'll go through it with you right now, and hopefully it will help. Number 1, find the area of a circle with radius 12. Area of a circle equals pi r squared. If the radius is 12, then area equals pi 12 squared. 12 squared is 144, so the area exact is 144 pi. Number 2, find the radius of a circle if the area is 81 pi. So again, the area of a circle is equal to pi times the radius squared. We're asked to find the radius. We're given the area, so I can put the area in for A, 81 pi, and that equals pi r squared. And I can solve for r. I'll divide both sides by pi. I can cancel here, and I get 81 equals r squared. And the square root of both sides gives r equals 9. So the radius of the circle is 9. Number 3, find the area of a circle with diameter 30. Area equals pi r squared. This time we're given the diameter to be 30. Remember that the radius is equal to 2 times the diameter, the radius is equal to the diameter divided by 2. Or you could say the diameter is equal to 2 times the radius. But we're given the diameter is 30, so the radius is half of that. So radius is 15. So the area equals pi times 15 squared. So that's pi times 225. And that's the area of the circle with a diameter of 30. Then we're asked to find the circumference. Well, once again, if the diameter is 30, the radius is 15. So we can plug this into the circumference formula, which is C equals 2 pi r. So 2 times pi times 15 will give us the circumference, and that's 30 pi. So the circumference of the circle with a diameter of 30, change that to the radius equal to 15, becomes 30 pi. Number 4, find the area of a 210-degree sector in a circle with radius 12. Now I could make a picture. If that helps, I could sketch something. 210 is something like this. It's bigger than 180. Oops. So I can draw it something like this. Maybe it's going to be this area right here. And this is 210 degrees. And I'm being asked to find the area of this sector that's 210 degrees and has a radius of 12. Okay, the area of a sector is equal to the degree measure of the arc over 360. So the arc is 210, the degree measure of the arc, times the area of the whole circle. Well, the measure of the arc is 210 over 360 times pi, and r is 12 squared. This equals 210 over 360 times pi times 144. 12 squared is 144. So I'm going to simplify this. I'm looking for the exact answer. If it doesn't say, then give me the exact answer. And so the exact answer here will include leaving pi as pi. I can cancel out the zeros here. And I know that 4 goes into 36 9 times, and 4 goes into 144 36 times. I can cancel some more. 3 goes into 9 3 times. 3 goes into 36 12 times. I can keep going. 3 goes into 3 once, and 3 goes into 12 4. So I have 21 times 4 in the numerator times pi, and that's all over 1. So I don't even need to really include that, but I'll do it just to show you that this is still left as 1 down here. So 21 times 4 is 84, and we have pi, and then over 1 is just 84 pi. So the area of the sector with radius 12 and a 210-degree arc is 84 pi. Number 5. Find the area of the segment. Now remember, the segment is equal to the area of the whole sector minus the area of the triangle, and that's what leaves the area of the segment. So the area of the sector is x over 360 times pi r squared. The area of the triangle is 1/2 base times the height. So let's look and see what the area of the sector is. The area of the whole sector is going to be equal to 90 over 360 times pi times 10 squared. And the area of the triangle is 1/2. And since this is a right triangle, the base could be 10 and the height is 10. 10 times 10. Now I'm going to simplify this whole expression here. So I'll simplify first this one. 90 over 360 times pi times 100. Just multiply out that 10 squared. Oops. We're going to minus 1/2 times 100. Well, that's 50. So let's continue to simplify here. This is 1 and this is 4. 90 goes into 90 once. 90 goes into 364 times. I also see I have a 4 and 100 up here, so I can cancel this and make it 1, and cancel this and make it 25. So I end up with 25 pi minus 50, and that's the area of the segment that's left. Number 6. Find the exact area of the sector, then find the perimeter of the sector. So the area of the sector is equal to, just as it was up here, x over 360 times pi r squared. So we're going to find the area of the whole sector. That's equal to 100 over 360 times pi times 3 squared. That's equal to 100 over 360 times pi times 9. And I'm going to do some canceling here to get my simplified answer. I can cross off some zeros. You can simplify any way you like, any order you like. And then 9 goes into 9 once, and 9 goes into 36 4 times. So I'm left with 10 times pi in the numerator and 4 in the denominator. And I can simplify that a little bit further, this 10 and this 4, by dividing by 2. And so I get 5 pi over 2, or 5/2 pi. And that's the exact area of the sector. Just plugging in 100 for the arc measure and plugging in 3 for the radius. The perimeter of the sector is going to be equal to the distance all the way around the sector. So the arc length is equal to x over 360 times 2 times pi times r. So we're going to find the arc length here of this arc using the formula x over 360 times 2 times pi times r, which is the circumference. And then once we find this arc length, we'll add it to 3 plus, and this is also 3. So let's find the arc length first. The angle is 100, or the measure of the arc. They're both the same. 100 over 360 times 2 times pi times 3. That equals 100 over 360 times 6 pi. I'm going to do some canceling here. 6 goes into 6 once. 6 goes into 360 60 times. So I have 100 over 60 times pi. I can simplify that further. I'll cross off some zeros. And I can have 10 over 6. I can divide by 2 on the top and 2 on the bottom. I get 5/3 pi is the length of the arc that bounds in the sector. And then I'll add that to 3 plus another 3, because we're going to do the distance around. So that's plus 6. And that's the perimeter of the sector. Number 7. We're told that the area of a triangle is 20 centimeters squared, and the height is 8 centimeters. Find the base. Okay, first thing I want to write down is the formula. Area equals 1/2 base times the height. And I can substitute in, I'm given the area, so that will be 20, substitute in for area, equals 1/2. Now I have to find the base, but I'm given that the height is 8 centimeters. So I just plugged in everything I know. The area, the base, I don't know, and then the height is 8. So this becomes 20 equals, well, 1/2 times 8. I can do these in any order I want. They're all multiplication. So I'll multiply 1/2 times 8, and that gives me 4. And then I'll multiply that by b. Remember that multiplication is commutative and associative. I can move them around. Now I'm going to divide both sides by 4, and I get that the base equals 5. And that's number 7. Number 8. Find the area of the parallelogram. Well, I'm going to drop, let's see, let's just write down the formula first. Area equals base times height. So I have a base for this parallelogram, or I have this base, but I need to find a height. And that's the perpendicular distance from the one base to the other base. And I like to start in the corner here so we can use this end of the parallelogram, which is a triangle, to find some missing pieces. We need to find the height of this parallelogram. This is 60 degrees. This height is perpendicular to the base here. So this is 90. So I have 30, 60, 90 degree triangle. So I can find this distance, this height. If this is 60, then this is 30. This is the short leg. The hypotenuse is 2 times the short leg. So the short leg is 6 divided by 2. So the short leg is 3. If the short leg is 3, then the long leg of a 30, 60, 90 is 3 rad 3. So now I have enough information to find the area of this parallelogram. I have the base, which is 8. This whole thing is 8. This little piece right here is 3. But this whole thing is 8. So 8 times the height, which is 3 rad 3. And then I just multiply 8 times 3 on the outside and get 24 rad 3. And that's the area of the parallelogram. Number 9, find the area and median of this trapezoid. Here's a picture, but we need the formula. The area equals 1/2 the height times base 1 plus base 2. Well, let's see. I have this base. Remember, in a trapezoid, the bases are the two sides that are parallel to each other. So this is the base and this is the base. But I don't have this base here. I also don't have the height. Thankfully, however, the height has been drawn straight from the corner down, And this is a 45, 45, 90, so I can not only find the height, I can find this portion of the base and add it to 6. This right here, this section right here is 6 because this is perpendicular. So this is a 6 and a 6 here. Now to find this length, I can look at the hypotenuse of this 45, 45, 90. And remember that the hypotenuse is the leg times square root of 2. So to find the leg, I'll take the 4 times the square root of 2 and divide by the square root of 2. So to find the leg in this triangle, I just take 4 rad 2 and divide by rad 2, which gives me 4. So the 2 legs are equal to 4. And I can work backwards to double check. The leg times rad 2 is the hypotenuse, and yes, that works. So I can put the information now that I have found into the formula. 1/2 times the height of 4. Base 1 is 6, and base 2 is 4 plus 6, which is 10. So that's equal to 2 times 16, which is equal to 32. So the area of the trapezoid is 32. Now the median of the trapezoid, it's that segment that divides each of these other sides into congruent pieces, these legs, I guess we could call them, but the sides that are not the bases. So the meridian is equal to 1/2 base 1 plus base 2. It's equal to the average of the 2 bases. This length is equal to this plus this divided by 2. So 1/2 times 6 plus 10, and that's equal to 8. 1/2 of 16 is 8. And there's our meridian. Oops. Number 9. Okay. Number 10. We're going to find the area of the shaded segment. So in order to find the area of the shaded segment, we did one of these up above. We need to find the area of the sector first. Then we subtract from it the area of the triangle. And we're left with the area of the segment that we're asked for. So to find the area of the shaded segment, first we'll find the area of the sector. Then we'll find the area of the triangle, and then we'll subtract. So the area of the sector, this whole sector, is equal to x over 360 pi r squared. So that's equal to, well, this angle is 120, this arc is 120, they're congruent. That's 120, or they have the same measure, I should say. They have the same measure. 120 over 360 times pi times 12 squared. Now I can simplify this a lot. This becomes 1/3 times pi times 144. And that's going to equal, well, 3 goes into 144 48 times. So this cancels with this. This is 48. So 48 pi is the area of the sector. Okay, good. The area of the sector is equal to 48 pi. We're going to subtract from it the area of the triangle. So this triangle right here, what is the area of this triangle? Now this takes a little bit of work. I'm going to redraw it over here. Here's a circle. Here's the triangle. How do we find the area of this triangle? Well, area equals 1/2 base times the height. I know that this is 12, but I don't know what the height is, and I don't know what the base is. the height to that base. But because this is 120 degrees, this angle, this whole angle is also 120 degrees because it's a central angle. And if you drop a perpendicular from this vertex, it's going to bisect this angle. So this angle right here is 60 degrees. What does that mean? It means that this half of the triangle is a 30, 60, 90 degree triangle. Now remember, when you have a 30, 60, 90 degree triangle and you're given the length of one of the sides, you can find the other two sides. So if this hypotenuse to this 30, 60, 90 degree triangle is 12, then the height is half of that. So the height is 6. The height is half of this hypotenuse. This is the short leg. And then the long leg of the triangle is equal to the short side times rad 3. So this is 6 rad 3. So the base then of this whole triangle is equal to 6 rad 3 plus 6 rad 3. So that's 12 rad 3. Now I'm going to plug in the information that I have to find the actual area. Area equals 1/2 the base, which is 12 times the square root of 3, times the height, which is 6. So that's 1/2 times 12 rad 3 times 6. Well, 1/2 of 12 is 6. 6 times 6 is 36. I'm just multiplying everything that's on the outside, and then I'm left with rad 3. So this is the area of the triangle. So to find the area of the segment, I will subtract that from what we found earlier, the area of the whole sector. So the area of the sector is 48 pi. The area of the triangle is 36 rad 3. And so the area of that segment is this. I'm not going to simplify it any further. 48 pi minus 36 rad 3. And that is a lot of work to find the area of that little segment right there. Remember, you're solving for it indirectly. You're finding the area of the sector first, and then subtracting from it the area of the triangle, and then you're left with what we want, the area of the segment. So 48 pi minus 36 rad 3. Okay, number 11. We're told that this is a square because all these sides are congruent, and this is a right angle. And so we know this is a square, and the area is 24, find S. Well, area of a square is base times height, or S squared. These are all S. So it's S times S, or S squared. Let's plug in what we know for the area. The area is 24, and that equals S squared. So I'm going to take the square root of both sides. So that's the square root of 24 equals S. And I can simplify, so I just took the square root of both sides. I can simplify this radical. S equals, let's see, there's a perfect square in there of 4. 4 times 6. And this reduces down to 3 times 2. So I'm going to take out the perfect square, which is 4. I'm going to take out a 2 then, because that's 2 times 2. So there's a pair of 2's. I take out a 2. And what's left inside the radical is 3 times 2, or 6. So 2 rad 6 equals S. And that is the length of the side of the square. Okay. Happy studying. See you tomorrow.